Hi there. We're going to move on to our next topic. Our aim for today is what are oxidation and reduction? Today we're going to talk about how electrons are going to move through a reaction, and we're going to use the skills that we learned in assigning oxidation numbers to help us see that. Now, there are two mnemonic devices that can help you figure out which is which. One of them, oil rig. That's a real thing. Perhaps you can imagine a picture of it in your mind. It stands for oxidation is losing electrons. And then when we continue, reduction is gaining electrons. I should have put an electron there. Okay. Now, the mnemonic device that I was taught when I was in high school is something that was very vivid because my chemistry teacher made it come alive. And this is the one that I have come to favor, but either one will work. You will see there's a gigantic diagram of a lion here in the center. And that's because my friend here, Leo the lion, says grrr. And that's what helps me remember that losing electrons is oxidation, Leo. And he says grr, spelled a little funny. Gaining electrons is reduction. Now, whenever I do oxidation and reduction problems, I actually write this mnemonic device right towards the top of my paper. Okay, let's take some introductory notes first. Reactions where one species lose electron must also contain a species that's going to gain one. We do not leave electrons by the side of the road. We cannot abandon them. There always has to be a receiver for one that is donating. Okay? Now, since both of those have to happen at the same time, we call these reactions redox, which is sort of a squishing together of the two words, or short for oxidation-reduction reactions. And so oxidation, reduction, or redox reactions require that an electron is transferred from one element to another. And they also require that we have changes in the oxidation numbers or the oxidation states. You may see either term. One way to identify oxidation is that the oxidation number becomes more positive. It may not actually be positive, but becomes either larger in the positive direction or more headed towards the positive direction. Reduction, on the other hand, your oxidation number becomes more negative. It may not actually get negative, but it heads more in that direction. A quick compare and contrast. Oxidation is the complete loss of electrons. In my mind, I say Leo. It's also possible that you'll be talking about a covalent substance instead, so there's not a total transfer like we spoke about with ionic compounds. So you're actually going to see electrons just shift away and spend more time with another atom within that bond. These two are both talking about the same thing, where there's a slight or complete loss of electrical charge, and it's negative. So because we are losing a negative charge, our oxidation number increases or gets more positive. Then we come over here, reduction, or grrr. We have the complete gain of electrons. Now, another way we could say that, talking about covalent molecules, is that electrons will shift towards that particle or that element within the covalent bond. Now, because we are gaining a negative charge in this case, that means that the oxidation number is going to decrease or get more negative. Let's start with some problems. What you're going to be asked to do is to identify the species or the element that gets oxidized and then also identify the species or element that gets reduced. So these should be two different things. We'll start with something simple. I'm starting with some magnesium. I'm adding some sulfur. Now both of those are in their elemental state, but through the reaction they join together into an ionic compound. So our first step, we have to assign oxidation numbers according to the rules that we learned in the previous video. So magnesium and sulfur are both uncombined. They are not attached to anything else other than themselves at this point. Whereas on the product side, Mg and S are so close together, that means they're bonded and they've made a compound. So the rules from our other video tell us that uncombined elements have an oxidation number of 0. So I'm going to label both of them with a 0 on the reactant side. Now what we need to do is to figure out what would be the oxidation number of each element when it's on the product side, when it's in a compound where the sum is 0, but actually both of these particles will have a charge. You're going to refer back to your periodic table in order to help you. One of the first things I can tell you is that magnesium in the group of 2 will always have a +2 charge if it is attached to something else. Now, because this must add up to 0 and there's one of each particle, you should be able to infer that this is going to be a -2. The oxidation numbers must always be a whole number, and in this case they're going to sum to 0. Now what we need to do to figure out which one is oxidized is we need to figure out which one gets a loss of electrons and becomes more positive. I see magnesium goes from 0 to +2. So it is the magnesium, specifically this magnesium right here, that is getting oxidized. I then look for the species that's getting reduced. I am looking for something that will gain electrons, and so I'm going to be looking for something that becomes more negative. I see my sulfur here starts out as a 0, and then through the reaction it becomes -2. So this substance right here, the sulfur, is the one that gets reduced. Now, it's going to be one of our reactant particles that is either oxidized or reduced. Please don't pick something from the product side. All right. I think now we're ready to try something a little bit more difficult. Let's try to step it up a notch. Okay, again, your task. Identify the species oxidized and the species reduced. In this case, we have 2 particles of potassium bromide. We're going to add some chlorine to them. Through the reaction, we get 2 particles of potassium chloride and a bromine particle that goes with that. So, the first thing that I want you to do, don't get freaked out by those coefficients. We're just going to ignore them at this point. So what I have underlined here in orange, we're going to ignore. Just like before, we need to assign oxidation numbers according to the rules. So when I look, the first thing I want to look for, do I have any elemental or uncombined elements there? K and Br, those are 2 different elements. Those are combined into what's known as a compound. Now, this chlorine right here is bonded with itself. That's another way of saying that that is elemental or uncombined. I then look through over to the other side, K and Cl, again a compound, but I have a bromine that's bonded with itself. So that is also elemental. Now, using your periodic table, I'll give you a hint. This potassium in group 1 always has the same charge. When it's attached to something else, things in group 1 have a +1 charge. The same thing is true over here. Since it's in a compound, this is going to have a +1 charge. Now, because there's one of these and one of those, it must sum to 0. The oxidation number here is a -1. Here here, because one of those, this is a positive one. This must be a negative one. And so we have assigned oxidation numbers. The next thing that we need to do is to take a look at how each element and its oxidation number changes through the reaction. So I've made a list K, Br, and Cl because that's the way they're written here. On the other side, I wrote exactly in the same order, even though they got mixed up a little bit here, so it was easier for me to see what was happening. Now, something that's different about this reaction is that potassium has a +1 charge at the beginning, and it has a +1 charge at the end. There's absolutely no change. What you need to see is that no change in this oxidation number means that potassium is not oxidized and it's not reduced. It just sort of spectates. All right, now the next element that we're looking at, the bromine, goes from a -1 to 0. Now it's not getting more negative, it's actually getting less negative, or you could say it's getting more positive. And so since this one is getting more positive, this is the thing that is oxidized. I look at the chlorine and I see how that changes through the reaction. I see my chlorine starts with an oxidation state of 0. Through the reaction, it winds up at a -1. So through that reaction, the chlorine actually gains an electron. GR tells me that that has been reduced. So I used exactly the same strategies. I ignored the coefficients, just put those out of your head. I then assigned oxidation numbers and then examined how they change through the reaction. Something that gets more positive gets oxidized, and something that gets more negative gets reduced. All right, I think you're ready to try a couple. I would like you to copy down both of these reactions onto a piece of paper, and I'd like you to do these 2 steps right here for both. Bring it in tomorrow and we'll see what has gone on. You're going to assign the oxidation numbers for all of the different particles. Then what I want you to see if you can do is to see if you can identify the species that gets oxidized and the species that gets reduced. Good luck, and I'll see you tomorrow.